Recording.
Yeah.
Okay, morning once more. Welcome to this session. Anyway, we have to continue to where we have stopped last time. Let me just remind you what we did. Um, we were talking about purely a random process or a white noise, um, where we just want to check a white noise given autocorrelation functions. So we just want to check on that. Okay, patient while opening. Okay, there we are. Yes, we were here last time, isn't it? I said, let's suppose that you have a data, okay, representing the auto or the estimated autocorrelation functions. And the question says, check whether this data is purely random process or a white noise. So for the data to be a white noise or purely random process, the absolute value of the estimated autocorrelation functions must be less than 2 over the square root of n. N, I told you that is a sample size. However, if sample size is not given, we use the population size, okay? So now, I said, let's consider this example 2.2.1, where you have been given 200 observations. Those are the sample size on a time series. That follows the simple autocorrelation functions. 200 observation on a stationary time series, which follows a simple autocorrelation function. Oh, sorry. Follows a simple autocorrelation function. Autocorrelation. Or autocorrelation, you can say simple autocorrelation function or simple autocorrelation, it's the same thing. Okay, and the table is like this. You've been given the leg K, where K is ranging from 1, 2, 3, 4, and 5. Okay, and the simple autocorrelation function, which is rho K estimated. Okay, this is your table or your data if you want. So the estimated autocorrelation functions at leg 1 is 0.59. The autocorrelation function at leg 1. So at leg 2 is 0.56. At leg 3 is 0.46. At leg 4 is 0.38. And then at leg 5 is 0.31. Those are the autocorrelation functions. So okay, just divide it here to be a table. Do it like this to be a table. So this is the table that is given. So we want to check whether this data is a purely random process or a white noise. Where do we start? Where do we start? Remember, a sample size n is equal to what? 200, isn't it? Okay, they gave you that. So now you can be able to calculate 2 over the square root of n, which is equal to what? Who can calculate it for us? 2 divided by the square root of n.
I think it's 0.1414213562.
Oh, 0, comma, to 3 decimal places, please. 0, comma 1.
141.
141, yes. Thank you very much. So this is our what? 2 divided by the square root of n. And remember, we just want to check whether the absolute value, by absolute value, we are referring to both positive and minus, absolute value of the simple autocorrelation functions, all of them must be less than 2 over square root of n. In other words, row 1, row 2, row 3, row 4, row 5, all of them must be less than 0.145 for the data to be purely random process or white noise. So tell me, is it a purely random process? Is it a white noise or not? Anyone? Is this data a white noise or not?
I think it is.
It is.
Yes.
So in other words, you're telling me that the absolute value of the estimated autocorrelation function of row 1, all of them are less than 2 over square root of n. In other words, what we're saying is row 1, row 2, estimated, remember? Row 3 up to row 5, estimated. All of them are less than 0.141. Is what we're saying.
Oh, no.
It's the opposite, isn't it? It's the opposite of this one. All of this, all of row 1 up to row 5 estimated are greater than 0.145. Therefore, the data is not a white noise, okay? Because all of them are greater than 2 over the square root of n. So how do we write it? Let me just go to the second page. You can say since row 1, or let's say okay, let me say since row k absolute value estimate is less than 0.141. Since the estimated autocorrelation functions at like k is less than 0.141, for k equal to what? 1, 2, 3, 5. Therefore, the data is not a white noise. It's not a white noise, or it's not a purely random process. You get that?
Yes.
Since the estimated autocorrelation function at like k is less. It's not less, man. It's greater. It's not less. Can you see that? They are greater, all of them. Since the estimated autocorrelation function at leg k is greater than 0,141 for k equal to 1, 2, 3 up to 5, the data is not a white noise. Okay, let me just go back so that you can see it clearly. You see here, this is the estimated autocorrelation functions at leg 1 is greater than this one. You see that? Even this one is greater than this one, and this one is greater than this one, and this one is greater than this one, and this one is greater than this one, which is opposing this statement there. Therefore, our data is not a white noise. I think it's clear. Anyone who don't follow? Or if you have any question, it's clear, isn't it? So this is how you check whether the data or the process is a white noise or not. Okay. Now, let's go to something else now. We just want to estimate. Remember here, they have estimated the autocorrelation functions for you, isn't it? For row 1 is this one, for row 2 is this one, for row 3 is this one, and so on. They estimated it for you. So there, you are supposed to do that. You are supposed to estimate the autocorrelation function by yourself. So how do you do that? How do you estimate the autocorrelation functions and the autocovariances, the mean and the variances? Let's go there. Let me use this one. Just want to show you the formula on how to estimate the autocovariances, autocorrelation functions, the mean and the variances. Let's say estimation of mean, variance, autocovariance, and autocorrelation. Okay, so this is the one. But let's start by estimating the autocovariances and autocorrelation. Let me start by estimation of autocovariance or autocovariances. So how do you estimate the autocovariances? Remember, the autocovariances is abbreviated by gamma k. Still remember, this is the autocovariance function at leg k. So because now we're estimating it, you have to put a cap on top to show that indeed we are estimating the autocovariances. Gamma k estimated. Okay. So the question is, how do you estimate the autocovariances now? Those are the formulas on how to estimate them, autocovariances. Remember, estimated autocovariance at leg k. In other words, you're going to estimate gamma 0, gamma 1, gamma 2, gamma 3, and so on, up to gamma k. So this is the estimation of autocovariances. Start from gamma 0, gamma 1, gamma 2, until gamma k. So now, let's start with gamma 0. How do you estimate gamma 0? So gamma 0 estimated, okay? It's always equivalent to 1 over n summation of xt minus x bar all squared, where t is ranging from 1 up to n. Are we together? The estimated autocovariance at leg 0 is equal to 1 over n, the summation of xt minus x bar all squared, where t is ranging from 1 up to n. Okay, and in this case, x bar is a sample mean, okay, which is equivalent to 1 over n summation of xt, where t is ranging from 1 up to n. I think this one is clear. So this is how you estimate the autocovariance at leg 0. Okay. So now let's go to the estimated autocovariance at leg 1. Can I go to the next page, please? Move to the next. Okay, thanks. Want to estimate the autocovariance at leg 1. So it's gamma 1 estimated, okay, which is equal to 1 over n summation xt x bar close brackets xt plus 1 minus x bar close brackets, where t is ranging from 1 up to n minus 1. So this is the formula that you can use to estimate the autocovariance at leg 1. Okay, then you continue to gamma 2 is going to be equal to 1 over n, the summation xt x bar xt plus 2 minus x bar close brackets, where t is ranging from 1 up to n minus 2. So this is the formula you can use to estimate the autocovariance at leg 2. Like I said, you just have to get all of them until you reach gamma k. So gamma k will be equal to 1 over n summation t equal to 1 n minus k of xt x bar xt plus k minus x bar. So this is the formulas generally that you can use to estimate the autocovariance at leg k, where k is ranging from 1 up to infinity. Are we together? Any question before we proceed to the estimation of autocorrelation functions? So this is the estimation of autocovariance. So now we are going to proceed to the estimation of autocorrelation functions or autocorrelation functions or autocorrelations. Okay. So now let's go to the estimation of autocorrelation or autocorrelation functions, which is abbreviated by rho k estimate. So this is how you estimate. Okay. So where do we start? Start from rho 0. From the properties of the autocorrelation functions, you know that rho 0 is always equal to 1. The same applies to the estimated autocorrelation functions at leg 0 is going to be rho 0 estimated is equal to 1 as well. So I don't know whether I can proceed to the next page. Okay.
Yes.
Row 0 estimation is always equal to 1 from the properties of autocorrelation functions. We know that row 0 equal to 1. Even the estimated row 0 is going to be equal to 1. So what about the estimated row 1? You know that is equal to the estimated gamma 0, not gamma 0, sorry, estimated gamma 1, okay, over estimated gamma 0. So this is the estimated autocorrelation functions at leg 1. It's equivalent to the estimated autocovariance at leg 1 divided by the estimated autocovariance at leg 0, which is written in that form. Okay, but I've already shown you the formula of the estimated autocovariance at leg 1 and the formula for the estimated autocovariance at leg 0. So we can substitute there. So which is equivalent to it's 1 over n summation xt x bar close brackets xt plus 1 x bar close brackets t equal to 1 n minus 1. Okay, then you divide by what? 1 over n summation xt x bar close brackets square t equal to 1 over n, isn't it? Okay, so this one cancel this one, isn't it? Then you are left with, summation of xt x bar xt plus 1 x bar divided by summation xt minus x bar all squared, where t ranging from 1 up to n, t ranging from 1 up to n minus 1. So that's it. That's row 1 estimated. It's clear, isn't it? That is the estimated autocorrelation function or estimated autocorrelation at leg 1. It's given by that formula. So if you want to calculate the estimated autocorrelation function at leg 1, given, maybe you are given the data, so you have to use those formulas. Okay, now let's go to the estimated autocorrelation function at leg 2. So you know that row 2 estimate is equal to gamma 2 estimate over gamma 0 estimate. Okay, so this one also is going to be equal to summation of xt x bar xt plus 2 x bar. Okay, where t ranging from 1 up to n minus 2 divided by what? Summation of xt minus x bar all squared. And t start from 1 up to n. So this is the formula for the estimated autocorrelation functions at leg 2. I think it's clear. So now we can just generalize it and go to the what? The estimated autocorrelation functions at leg k. Okay. We have the estimated autocorrelation function at leg 1, the estimated autocorrelation function at leg 2, then you can just generalize it to the estimated autocorrelation function at leg k. So how do you write that? So can I go to the next? Think so. So until okay, so it's equal to gamma k estimate over gamma 0 estimate, okay, which is equivalent to the summation of xt x bar xt plus k x bar divided by sum of xt minus x bar all squared, t ranging from 1 up to n, t ranging from 1 up to n minus k. So this is the formula you can use to calculate the estimated autocorrelation functions at leg k. Okay, I think it's clear. Now we can just go to what? To example. Show you how do you find them now using the real data set. So for those who are having the lecture notes, I think there is one example there on page, just check it for you, on page 38. Let's check page 38, example 5.2.1a. See that one? Okay, let me just write it down. Example. It's example 5.2.1a. Okay. And you have been given a data. Okay. T is ranging from 1 up to 4. Okay. And then xt, we've got x1, which is 4. x2 is 5. x3 is given by 2. And x4 by 5. So this is the data given. Now, they want us to find the estimated gamma k, okay, and estimated rho k, okay. Okay, I'm going to do one example on how to calculate the estimated autocovariance at leg 1, that is gamma 1 estimate. Okay, then from there I show you how to find the estimated autocorrelation functions at leg 1, that is rho 1 estimate. Then the rest you'll do it. The rest you're going to do it on your own. It's very simple. Okay, now let's start. Where do we start? Anyone?
We can find the mean of xt.
Okay, we find the mean first. Okay. By mean, you are referring the simple mean, isn't it? To the simple mean, isn't it? You said you have to find x bar, which is equal to 1 over n summation of xt, t ranging from 1 up to n. And again, you have to find, who can tell me, what is the sample size?
4.
4. Remember, in some cases, you have to listen. In some cases, instead of giving you T, they can give you K. It's the same thing. They can give you K or T. It's the same thing. Okay. But anyway, it is going to change the formula there. Instead of T, you're going to have K. But anyway, normally we have to give you T so that it can be the same as the one on the formula there. Okay. So our sample size is 4. So, and we just want to find the sample mean. Sample mean is going to be calculated as 1 over 4, in brackets, x1 plus x2 plus up to x4. Okay, which is equal to 1 over 4. X1 is what? It's 4, isn't it? 4 plus 5 plus 2 plus 5. Can you tell me the answer?
It's 4.
It's 4. So our sample size is 4. So that means now we have our sample size. So we can use the formula of autocovariance at leg 1 now to calculate the estimated autocovariances. It needs us to go to the next page. I think you're done. Hope so. Let's go to the next step. The next step is to find gamma 1 estimate. Okay. Remember, gamma 1 estimate is the same as 1 over n summation xt x bar xt plus 1 x bar, okay, which is ranging from 1 up to n minus 1, okay, which is equivalent to n sample size is 1 is 4, so it's 1 over 4. Okay, then from there x1 minus x bar, you can tell me, can't you remember? X1 is what?
It's 4.
4 minus
4.
4. Okay. Then x1 plus 1, x2 is what? X2 is
5.
what? 5. So 5 minus 4. Okay. Then you said plus. Remember, we're adding from 1 up to what? Up to what? 3, isn't it? Because it's 4 minus 1. It's up to 3. So this is the first step. Second one is what? You have to go to x2. So this one is supposed to be like this. X2 is 5, isn't it? So it's 5. Yeah, I think so. It's 5. Hey guys. Okay, it's fine. Okay. X 5 minus 4, isn't it? Then 2 plus 1 is x3, so it's going to be what, equal to what? 2 minus 4. Do you follow?
2. It's 2 minus 4.
Yes, then plus the next one is going to be 2 again minus 4 and what?
5 minus 4.
5 minus 4. That's very good. Then you close it. Then you tell me the answer now.
Minus 1.
Yes, minus 1. because it's going to be minus 4 over 4, which is minus 1. I hope you follow. Then gamma 0 estimate, remember it's 1 over n summation xt minus x bar all squared, where t is ranging from 1 up to n, which is 4. Let me write 4 n. So that means you're going to have 1 over 4. Okay. X1 is 4 minus 4. Then it's squared. Say plus. X2 5 minus 4 squared plus x3 2 minus 4 squared plus x4 5 minus 4, then you square it, then you close the bracket. Then tell me the answer.
3 over 2.
Over 2.
3 over 2, which is equivalent to 1.5, isn't it?
Yes.
Then say 3 over 5, 3 over 2 or 3 over 2 or 1.5, the same thing. So now you have got the estimated autocovariance at leg 1 and the estimated autocovariance at leg 0. So we want to find the estimated autocorrelation function at leg 1. That is row 1 estimate, which is equivalent to gamma 1 estimate or gamma 0 estimate. Okay, which is equivalent to what? Minus 1, isn't it? Over 1,5, isn't it? Tell me the answer.
Minus 0,667.
Yes, up to 3 decimal minus, sorry, minus 0,667. Okay. Okay, that's it. So this is how you calculate the estimated autocorrelation function at leg 1. So like I said you have to calculate the estimated autocorrelation functions at leg 2, leg 3, and leg 4. So please do it for me. So after getting this value, you go back to that data or a table. Go back here. Here's what? Gamma 1 is 1,5. This one is 1,5. 1,5. Okay. This one is minus 0,667. Okay. So I want you to calculate this one for me. This one, that one, this one, and that one. Okay. Then from there, we check whether the data, but because now we have a simple set. Eh?
Is gamma 1.5 or -1?
Oh, it's -1. Yes, yes. Thank you very much. Thank you very much for that. It's -1. Thank you. So yes, -1. Thank you. Let me just erase it. Ah, la, la. Thank you for that. It's -1 because it's coming from here. This is the one. So 1,5 is gamma 0 and we don't have it there. and row 1 estimate is this one. Okay, so please calculate estimated autocovariance at leg 1. Tell me the answer. I'm giving you let's say to finish the whole table, giving you 7 minutes. It's too little. Yeah, but you have to learn to be fast. I'm giving you 7 minutes. So at 8:30, you should have been done. I'm giving you only 7 minutes. 8:30, you're going to tell me the solutions. Okay. Oh, you just want to go one by one. Okay, let's go one by one. Start with the autocovariance at leg 2 and autocorrelation function, estimated autocorrelation functions at leg 2. Let's start by one by one. I'm giving you 2 minutes for this one, 2 minutes for this one, the other one, and then 3 minutes for the last one. But 3 and 4, I think they're simple. Let's say 3 minutes for the first, 2 for the last two. So far you're left with one, with 2 minutes, sorry. So 26 should have been done. 26 past 8 should have been done by on calculating gamma 2 estimate and row 2 estimate. Yes, anyone gamma 2 estimated?
Is it 1/4?
Got 1/4. That's correct. What about others? You're still, yeah, you're getting the same answer. Yeah, it's 1/4, yeah. Unless if there is somebody who got something different. Okay, let's go to the estimated autocorrelation functions at leg 1. Leg 2, sorry.
You want the answer?
Yeah, the answer.
0,167.
That's correct. Zero comma 167. That's very simple. Okay. Hey, no.
Are you writing on the correct?
Sorry for that. What is happening? It's down here, isn't it?
Yeah.
It's 0,167. Okay. So now, estimated gamma 3, this one,
0.
definitely 0. Estimated rho 3,
0.
it's going to be 0 as well. Estimated gamma 4,
0.
0, right? Estimated rho 4,
0.
0. So you see now, we've got zeros for 3 and 4. And can you be able to draw a plot, autocorrelation plot? Still remember to draw a autocorrelation plot?
Yeah.
I think I showed you. You're supposed to have something like this. This one is row K estimate. This one is like K. So it's 1, here's 0, here's 1, 2, I mean I did that 4, 3, and 4. Okay. So the estimated autocorrelation function at leg 1 is minus what? So that means because it involves minus, we go down here. So this one is minus 1. Okay. For 1 is minus 0 comma something. Let's say it's here. This one is 0 comma 5. So 0 comma 6 is somewhere here. So you can just say it's here. Okay. And then the for row 2 is here. It's positive, remember? And it's what? 0 0,16 something. So this one you can say is 5. 0 0,5, sorry. And then a 0 0,1 somewhere here. So you can say it's here. Okay. But here we don't have the limits. You can just see. But all of them are within the limits. I think so. I'm not sure. But this is how you draw. Don't bother by indicating the limits because you don't know where to indicate them. Just leave it like this. So this one is the autocorrelation function plot. Any question? So it's supposed to be like that. Okay. Think it's clear. So any question related to this one, you're going to get it right. Okay. Now let's go to the estimation of the mean and the variance. Estimating the mean and the variances. Unless if there is somebody who's having a question. Do you have a question? Okay, none. Okay, now let's go to the estimation of the mean and the variance. Okay. Let me just write down estimation, or we can go to the next page here. Estimation of mean and variance. Let's start by estimating the mean. But before that, let's say we have this process xt is equal to mu plus zt be a stationary process okay, with expected value of zt, which you know that is always equal to 0, and the variance of zt, which is equal to sigma squared z. Then x bar, as you know, is given by 1 over n summation of xt, where t is ranging from 1 up to n. Okay. Now, the expected value of x bar, okay, would be equal to what? We introduce expectation on both sides. So we're going to have the expected of 1 over n summation of xt, where t is ranging from 1 up to n, then close brackets, isn't it? So this can also be written as what? As because 1 over n is constant, you can take it out, isn't it? As 1 over n, okay, open brackets, summation of what? Expected value of xt, where t is ranging from 1 up to what? Up to n. Are we still together? So this one again can also be written as 1 over n, open brackets, because it's a sum, we're summing, so it's like expected value of x1 plus expected value of x2 plus up to what? Expected value of xn, isn't it? Which is equivalent to 1 over n, open brackets, mu1 plus mu2 plus mu n. The question is how many mu's there? Okay, there are n of them, isn't it? So this is equivalent to 1 over n multiplied by n times mu, which is equal to what? To mu. Are we together? So therefore, the expected value of x bar is equal to mu. What does that mean? It means that x bar is an unbiased estimator of the population mean. Are we together? X bar is an unbiased estimator of the population mean. So you write it in this way. Can I go to the next page? Can I go to the next page?
Yes, sir.
Okay. I said therefore the expected value of x bar is equal to mu. What does that mean? It means that x bar is an unbiased estimator of the population mean. Okay. So if the question says prove whether x bar is an unbiased estimate of the population mean, you have to show me that the expected value of x bar is equal to mu. Are we together? That's it. So now we're estimating the what? The mean. Let's go to the variance. Now, if the process xt, okay, is a stationary process, okay, it's a stationary process with autocorrelation function of what? Rho k. Then the var of x bar, okay, to always be equal to gamma 0 over n, in brackets 1 plus 2, in brackets 1 minus k over n, close brackets, rho k, close brackets. See now, if you have got xt which is stationary, so with the autocorrelation function rho k, so var of xt is equal to gamma 0 over n, open brackets 1 plus 2, open brackets 1 minus k over n, close brackets rho k. Then we close brackets again. Okay. So now I will show you how do you apply this formula. We are going to apply this one. I will tell you how and when. Okay. So now let's say for argument's sake, if n approaches infinity, for those who are doing mathematics, therefore the limit n approaches infinity. Oh, no, there's something missing here. Sorry for that. We have a summation somewhere. Sorry for that. 2 and a summation here. Okay. Yes, t equal to 1 n minus 1. Sorry for that. I think it's not there on the lecture notes. Let me just verify before go further. Yeah, it's that one. Yeah, sorry for that. I forgot to put the summation there. So var of x bar is equal to gamma 0 over n. Okay, open brackets 1 plus 2. The summation of t equal to starting from 1 up to n minus 1. Open brackets 1 minus k over n, close brackets. Okay, I think this one is correct. Okay, now for argument's sake, let's say if n approaches infinity, so the limit of the summation of t ranging from 1 up to n minus 1 of 1 minus k over n rho k would be equal to what? For those who are doing mathematics, I think this one can get it right. Okay. If n approaches infinity, so the limit of n approaches infinity of summation of 1 minus k over n times rho k, where t is ranging from 1 up to n minus 1, is equal to what? Who can tell me? Who can guess? Who can try to work it out and give me the solutions here? Anyone? Especially for those who are doing maths. I think you can get it right.
That's it.
Yeah.
Can I guess?
Guess.
I think it will be approaching 0.
So then you are telling me that the answer is 0.
Yeah, I'm just guessing.
No, it can't be 0. Okay, let me just give you the answer.
1.
It's going to be
1.
the summation. Summation is going to be there. Okay? And then we're going to start from 1. But this time, because n is approaches infinity, we're going to start from 1 up to what? Infinity. Okay? Of what? Of rho k. So you can just go and prove this one. But let me just explain how did we manage to come to this solution. It's summation of rho k where t is ranging from 1 up to infinity. Why? Because in mathematics, if n approaches infinity, if the limit of n approaches infinity, the whole of this part, you see this one, if n approaches infinity, the whole of this part will tend to 0. Okay, so if this part tends to 0, so here within the brackets we are having only 1 and what? And row k. And remember, because n approaches to infinity, so we're going to sum from 1 up to infinity there. So that's why we're having this infinity there. And this row k is just because it's this row k times 1 here. Because here is 0, 1 minus 0 is going to be 1. 1 times row k is going to be row k. So that's why we're going to have this row k and this one. Okay, so now, if this is the case, so now the var of x bar is going to give us the new formula now. Okay, let me just go to the next page if you're done. You're done? Can I go to?
Yes.
Okay, now the new formula for the var of x bar will be more or less like this. Var of x bar will be more or less like this. You are still going to have gamma 0. Sorry. You're still going to have gamma 0 over n. Okay, then that big brackets 1 plus 2, then summation. This time around is going to start from 1 up to infinity. Okay, of what? Of row k. So this is the new one. So var of x bar will be equal to gamma 0 over n. So this one, instead of writing the big brackets, this is not necessary. You can write this one. You can write this one. I think it's the same thing. Okay, let's go back and check. Remember the whole of this part. Let me show you the whole of this part. This one. Now is this one. Okay, so that's why here, instead of having this part, we're having 1 plus 2 summation of row k t equal to 1 up to infinity. And then which is less or more like this one. So now let me show you where are we going to use these formulas. Okay, let me just write this one next to it so that you can see it clearly. Var of x bar is equal to gamma 0. There's something that doesn't make sense. Have you realized that? Yeah. Yeah, we are not supposed to have t. It's k, isn't it? Because where are you going to substitute t here? You see that? I think here we made a mistake. It's supposed to be t instead of k. Oh, it's supposed to be k instead of t here. Are we together? Because if you are having t here, where are you going to substitute that t from? So I think here is supposed to be k instead of t. Where there's t, just substitute by what? By k, please. These are the error, the human error. So let's rectify it. It's k. Where there's t, put k, please. Because it's a human error. I make a mistake. Yeah, now it makes sense, isn't it? Because here is k, so we're supposed to have k here. So here is k, you're supposed to have k here, and so on. Okay, now next Where does T put K, please? I think we made a mistake here. It won't make sense if we have T and K at the same time. Yeah, now I think it's fine. So now that other one is gamma 0 over n. 1 plus 2, the summation K equals 1 to n minus 1 of what? Of 1 minus K over n rho K. I think it's correct, isn't it? No, it's fine. So this is the formula. So now I just want to tell you where are you supposed to apply these formulas. The first one, you can apply it when we are dealing with the autocorrelation, autocovariance processes. Okay, this one you apply it when we are dealing with the AR processes. You know what is AR, isn't it? Auto-regressive processes. If you are having an auto-regressive process and the question says, find the var of x bar, you must know that you have to use this formula. This one. Are we together? However, if you have a moving average process and the question says, find the var of x bar, you have to use this one for MA processes. Okay, so we are going to apply this. Don't worry, next time we are going to apply this one. So you have got var of x bar, which is equal to gamma over n, open brackets 1 plus 2 summation of rho K, where K is ranging from 1 up to infinity. So that formula, you apply it when you have been given the auto regressive processes. Okay. However, if you have been given the moving average processes, you are going to use var of x bar, which is equal to gamma 0 over n, open brackets 1 plus 2, summation of 1 minus K over n, close brackets rho K, where K is ranging from 1 up to n minus 1. This is the one. If the processes, or if the process is a moving average. Clear? Any question? No question? Okay, I think we can stop here, but before we stop, let me just give you something to work on during the weekend, and I call it an exercise. Let me just give you this exercise. It's not related to this one, it's related to what we did last time. So I just want to see whether you can be able to come up with the answer. You have been given a process, xt, okay, which is equal to 1, 1.2 xt minus 1, okay, minus 0.2 xt minus 2, okay, plus zt minus 0.5 zt minus 1. Okay, so there are two processes in one. You have got the auto regressive and moving average, combine them together, it's ARMA. Okay, now first question says, number 1, determine whether the process or the model is stationary or invertible, and invertible. So otherwise, you can find that maybe this process is stationary and also invertible. Sometimes we find that, okay, it's not stationary, but invertible. Sometimes we find that it's stationary, but not invertible. This is what I'm saying, trying to say. The question says determine whether the process or the model is stationary or and invertible. That's number one. That's number one. Okay. Number two, I don't have a space here. Are you done? Number one, you have to determine whether this process is stationary. Yeah, again, you determine whether it's invertible. I know you know how to deal with this one. So let me just go to the next page. Number two, if it's not stationary, please find the first differential. Okay, let's say you find that it's not stationary. Just go further and find the first differential. But if it's stationary, it's fine. Leave it like that. That's number two. Number three, after doing that, you have to identify a model. So identify. And now it's going to be a new model or a new process. You can say a new model or a new process. You know what does that mean when I say identify a new process? I want you to, because there is a combination of two processes, remember? There is a autoregressive and a moving average process. So it's ARMA. Okay. So if it's ARMA, let's assume that you find that this process is stationary. So you're going to find something like this. Oh, sorry. So I'm including the seasonality. You're going to find something like this. Okay. Then this is for those who find that is what? Is stationary. For those who find that it's not stationary and they difference it once, you're going to find this one. Sorry. You're going to find this one. Those are the ones who find that it's stationary. It's not stationary, then they difference it. They're going to find it like this. You get it? This one's not stationary. So that means you difference here. This one is for stationary. So that means you didn't do anything. So those are the two cases. If you find that the process is stationary, so that means you are going to identify a new process using this one. If you find that it's not stationary, then you difference it once or twice, but I think once is going to be okay. And then you are going to identify this one for me. So what is P? P is the order of the autoregressive. Okay, the new order of the autoregressive. Remember here, the order of the autoregressive is what? Who can tell me? The order of P here is what? Anyone? The order of P
2.
is 2, yes. Okay, the order of Q? The order of Q is 1, yes, that's true. So for those who realize that, okay, this process is not is stationary, so you're going to find this thing, P to be equal to 2 and Q equal to 1. So therefore, you're done in your case. In your case, you're done because it's 2, 1. But for those other ones, they are going to find a new process. Their P is no longer going to be 2. It's going to be something else, I don't know, after differencing. And differencing, because the first differencing, you're going to find 1. Okay. Q is what? It's going to change or not? Anyone?
It will not change.
It won't change because we don't difference a moving average process. Moving average process is always stationary. So there is no differencing on that. So it's going to remain the same. Okay. I think I gave you a clue. Just go and try it. Then we are going to talk about on your next class. Any question? Any question?